Okay, this lesson is an introduction to triangles. If you remember a week ago, we did an introduction to quadrilaterals, and you saw how far we took that. So then we're going to now work with triangles. Today we're not going to do much in the way of computation. There's a couple numbers that we'll look at, but for the most part, you really won't need your calculator. So your goal for today is I can classify triangles based on their sides and on their angles. So we're going to learn how to talk about triangles regarding their sides and their angles. Just like we did with quadrilaterals, we talked about their sides being parallel and congruent, and we talked about their angles as well. So let's go ahead and get started. So a triangle is a closed figure, meaning that eventually all the sides meet together and they form a shape that is enclosed. But instead of four sides like a quadrilateral, a triangle has three sides or three line segments, and they also have three angles. And so that's why we classify them by their sides and by their angles, okay? And so just to review, this is a side, and this right here is an angle, okay? All right, so let's first talk about the different angles. In order to do that, it's sometimes really helpful to use a protractor. Now, we won't be using a protractor in class because we're not looking to identify specific angle measures, but we are going to be classifying them as obtuse and acute. And so it's important that we have a general understanding. So first of all, a protractor is used to measure angles. Right here we have a 90-degree angle, and you're very familiar with a 90-degree angle from when we did quadrilaterals. So if this was part of a triangle right here, I'm going to lay it on the base of the protractor, and if we look straight up, it tells us that this is 90 degrees. Okay, now a 90-degree angle is also called a right angle, and we talked about that when we were talking about quadrilaterals as well. Okay. Now we're going to look at a 75-degree angle. And when it's laying right on the protractor, right here, and it goes up, 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 and it falls in between this 70 and 80 mark, which is going to be 75. If an angle is less than 75 degrees, it is called acute, and we're going to look at that in just a second. Another acute angle example will be 40 degrees, and so it's going to lay again right here on the protractor, and it's going to measure 40 degrees. Now the reason why I'm taking the 40-degree angle here instead of the 140-degree angle is because I know that anything that is smaller than 90 degrees is going to be less than 90 degrees in measure. Here's an example of something that is greater than 90 degrees. So again, I'm going to lay it right on the protractor. And this will measure 130 degrees. And again, I'm using that 130 instead of the 50 because I know that it's much bigger than 90 degrees. It opens wider. So that's just kind of to get your juices going in your mind. Okay, so here we have an acute triangle. An acute triangle, all of the angles are less than 90 degrees. So down here I have a little protractor, and let's see if I can make it a little bit bigger. Okay, so if I'm measuring this angle right here, I see it's laying right on the protractor, and it's going to be almost 80 degrees. If I measure this angle right here, start it right in the middle, again, it's going to measure less than 80 degrees. And if I were to flip it around and measure this angle right here, it's also going to be less than 90 degrees. The other type of triangle that we have is called obtuse. So an obtuse triangle is going to have one angle, okay, one angle that is greater than 90 degrees. Okay, so again, I'm going to take my protractor, I'm going to make it a little bit bigger for you, and I'm going to measure this angle right here. I'm going to lay it right on the protractor, so you see right at the middle there, and you're going to see this is almost 120 degrees right there. Okay, but just by looking at it, you can tell that this opens much wider than 90 degrees. 90 degrees would look something like this. All right, and then another type of triangle that we measure by angles is called a right triangle. And this one should be the easiest for you because you know that a right angle means that it's 90 degrees. And so if I make my protractor nice and big here, you can see that this angle right here measures a perfect 90 degrees. Okay, and we can also look for that little square that shows us that it's going to be a 90-degree mark. Okay, so those are triangles by angles. We had acute, less than 90 degrees, obtuse, more than 90 degrees, and then right, exactly 90 degrees. Now we're going to look at them by the length of their sides. Okay, so the first type of triangle that we have by sides is called scalene. And I know it looks like a weird word, so just say it a couple times. Scalene, scalene, scalene. So scalene means that absolutely none of the sides are congruent. And remember, congruent means an equal length. So something that has the exact same measure, so 8 inches and 8 inches. But in a scalene triangle, none of these are going to be equal. And so, for example, this might be 4 meters, this might be 11 meters, and this might be 13 meters. Okay, another type of triangle we have is called isosceles. And again, that's another weird word to say. Isosceles, isosceles. Isosceles is when two sides are congruent. Okay, and again, congruent means equal. And so you'll see right here, you have the equal tick marks. This side is congruent to this side. So if this was 5 meters, this is also 5 meters, okay, isosceles. And then we have equilateral. Equilateral, or some people say equilateral, is pretty easy because you can see the word equal kind of hanging out in the prefix of the word, and that means that all of the sides are congruent. All of the sides are equal. If this is 5 meters, then this is 5 meters, and this is 5 meters. It's kind of like a square or like a rhombus. All of the sides are equal. Okay, so again, we have 3 types of triangles by angles, acute, obtuse, and right. And we had 3 types of triangles by sides. We had scalene, isosceles, and equilateral. Now, the big thing to know is that when you add up all of the angles of the triangle, they're going to equal 180 degrees. And we won't be doing much with the degree measures in 6th grade. You're going to do a lot more in 7th grade, but it is important to know that if I add up this angle and this angle and this angle, it's going to equal 180 degrees every single time, even down to the fraction and the decimal. Okay, one last note on triangles is there's another kind of crazy word, and it's called a hypotenuse. You can say hypotenuse. So the hypotenuse is the longest side of the triangle, and that's a rule. It's always going to be the longest side of the triangle. The other rule with the hypotenuse is that it's only in right triangles, okay? Only in right triangles. So you're going to see here in my examples, these are all right triangles, and you know that because this little square right here tells you that it's a right angle. Okay, and the way that you find the hypotenuse, well, although it's pretty easy to see that this is the longest side, is it's always opposite of the right angle. So if this is the right angle, this is the hypotenuse. If this is the right angle, this is the hypotenuse. If this is the right angle, this is the hypotenuse. So it's always going to be the longest side. All right, so before we finish, let's play a little matching game here. And I'm going to bring these guys up so that we can see them a little bit better. All right. I think I have some more down there. So we are going to try and match them in our chart. Okay, so let's just start off with number 1. So number 1 over here, it looks like this side is congruent to this side. So I have 2 equal sides. Okay, so that's going to tell me that I am somewhere in the isosceles category. But then it says this is a 40-degree angle. This is 40 degrees, and this is 100 degrees. And you'll notice those will all add up to 180. So if I have one angle that is over 90, that's going to be obtuse. So it's isosceles and obtuse. All right, let's do number 3 here. So number 3, they are all 60-degree angles, and all of the sides are congruent. So your flag should go off that that is equilateral, and if all of the angles are under 90 degrees, it's going to be acute. So equilateral and acute. I'm going to make that just a little bit smaller. There we go. Okay, so let's look at number 7 here. So number 7, this is not congruent to anything else. These are not congruent to anything else. And this is not congruent to anything else. So that's definitely going to be scalene because nothing matches. And then I have one 30-degree angle, one 50-degree, and one 100-degree. That 100 degree is over 90 degrees, so it's going to be scalene and obtuse. Okay, we have number 5 over here. I'll leave them over here while we talk about it. So this side is 3, this is 5, this is 4. And that means, oh, the announcements are behind me. So what that means is that all the sides are different lengths, but this tells me right here that I have a right angle. So it's going to be right, but it's going to be scalene because all the sides are different. All right, let me grab number 6 here. So number 6, oh, I see I have a right angle, and the only spots I have left are equilateral or isosceles. But it looks like I have 2 sides are the same, but this one is not the same. So that's going to be isosceles. Let me bring this guy up here, and this guy over here. Am I missing more? Nope. Okay, so, oops. Oh no, I took him apart. All right, so this number 2 guy over here, he's fallen apart. All right, so none of the sides on number 2 are congruent because this has 1 tick mark, this has 2, and this has 3. So that's definitely going to be scalene. Now in this one, I do not give you any specific mention about angles, but what you should be able to see is that these are all less than 90-degree angles. There's nothing that is bigger than a right angle, and so he is going to be acute and isosceles. And last but not least, we have number 4 over here. And he has isosceles also because he's got 2 tick marks, okay? And he also looks like he has acute angles. Oh no, I'm sorry. This guy is scalene. He's got no congruent sides. And this guy is the isosceles and the acute over here. All right, now that I have thoroughly messed up that game, that is the end of the lesson. Again, just a quick introduction. Make sure that you ask me any questions if you have them, because the next lesson we will be calculating some area.